Okay, myself Prashant. Let's start the Markov chains and have a meaningful discussion on Markov chains. Markov chains are the process which can depends on the current states for the moving for the next state. Okay, it can depend on the only current state. It can depend on before current state or after the next state. It depends on the current state, and we have some important definitions in Markov chains, that is probability vector. Probability vector is a by a vector we simply mean that n tuple number of n tuple of numbers v1 v2 up to the vn. v1 v2 up to the vn is the n tuples where the quantities are v1 v2, that's are small v1 v2 n tuples, and quantities are capital v1 capital v2 up to the capital vn are called components of the vector. Or one more definition, a vector v is equal to v1 v2 up to the vn is called a probability vector if each one of its components are non-negative. Okay, if one of is non-negative and their sum is equal to 180. For example, this is the easiest one and meaningful definition. Consider v1 v2 vn is called a probability vector. The components must be non-negative. Example, u, consider u 1 comma 0. 1 comma 1 is a non-negative element and 0 is a non-negative element. By adding this, we should get an equal to unity. Unity means 1. Sum is equal to 1. And u 1 by 2 1 by 2. Okay, v is a vector consisting of the components 1 by 2 1 by 2. The sum of these are non-negative. The sum of 1 by 2 and 1 by 2, it should be 1. It is the major rule of this probability vector. Okay, consider another w 1 by 4 1 by 4 1 by 2. There are three components, all are non-negatives, and by sum of these numbers is equal to unity. Okay, let's move on to the next one. Stochastic matrix. Stochastic matrix is a square matrix. You know the square matrix, number of rows is equal to number of columns, is also called as square matrix. A square matrix P is equal to Pij having every row in the form of probability vector is called in the form of probability vector. Okay, you know the meaning of probability vector. Probability vector is a component of non-negative numbers. By adding these row numbers or numbers, we get an unity. Stochastic matrix is a matrix having the form of probability vector. For example, consider I2. I2 is the 1 comma 0 0 comma 1. This is a 2 cross 2 square matrix. 1 plus 0 is equal to 1. 0 plus 1 is equal to 1. And consider I3. 0 plus 1 plus 0 plus 0. First see about these are non-negative or not. 1 is a non-negative, 0 0 non-negative, 0 1 0. By adding particular row, we get sum is equal to 1. 0 1 0 sum is equal to 1. 0 1 0 sum is equal to 1. Okay, move on to next definition. Regular stochastic matrix. Regular stochastic matrix is a stochastic matrix. You know the stochastic matrix meaning above one. Regular stochastic matrix is a stochastic matrix. P is set to the regular stochastic matrix if all the entries of a sum power p power n are the positive, means 0 not be accepted. But okay, let's detail with the example. Going through example, take an example A. It must be a probability vector and it must be a square stochastic matrix. Stochastic matrix is a non-negative number. By adding we get a 1 1 by 2 n by 2 adding 1 1. it is a stochastic matrix, but 0 is not accepted in the regular stochastic matrix. By multiply with the here n is equal to 2. N is equal to 2 means multiply same matrix with 2 times 1 2 1 2 a power 2, and up to where we have to multiply these vectors for up to the eliminating the 0, eliminating 0 in the matrix, and getting stochastic matrix. 1 by 2 plus 1 by 2 1, 1 by 4 plus 1 by 3 by 4 1. It is a stochastic matrix. This is called a regular stochastic matrix at the n is equal to 2, but n from range 1 to infinity. Okay, thank you. Okay, okay, let's start, guys. We can take a concept of what is important definition in Markov chains, what is probability vector, and what is stochastic matrix, and what is is regular stochastic matrix, and etc. So we can solve by using program, some any other language you can. We are so easily get and familiar with the Python language, so I can choose the Python. So start with the first line. In the first line, we taken a from fraction import fraction. It is for the printing the fixed unique probability vector in fraction form. So to find the given matrix is stochastic or not, we can use a function name called is underscore stochastic of p. P is a matrix for row in I. Row is a row in P. In P means if it is first row, consider if it is 3 cross 3 matrix, consider a row, check it is equal to 1 or not, and increment by row, second row, third row. Okay. If it is, if we not observed, if it is should not be, must or should not be negative value or entries in the matrix. So return true. If it is rows sum is equal to 1, return true, then it's over for the stochastic, and it is stochastic. Okay. If it is regular stochastic or not, to find that we can use a function called regular stochastic matrix. We can use two arguments or parameters p comma max power is equal to 100. P is a matrix, max power is the power of that matrix is equal to 100, up to 100 or less than 100. Consider all entries or max power entries are positive or not, you must check. So if not in stochastic of p, if not is stochastic of p means stochastic of p, return false means return false if matrix is not stochastic. We know that if the regular stochastic means it should be stochastic only. So if it is not, return false. Okay. We have to get a or length size of p and power matrix, and one more matrix, copy matrix. So we should multiply the two matrix. We can use a range. You can use a range function for loop from 1 to max, up to the max power means 100. We can take a 100 as a max power in above function. Power matrix is equal to matrix multiply. Matrix multiply is here we see that matrix multiply is a another function used for the matrix multiplication. We can use it in the above. Power matrix is equal to, that is copy matrix. We have showed the copy matrix in power matrix. Power matrix itself is equal to matrix multiply of power matrix and previous matrix p. Okay. Then we must have positive power, so that's why use a if loop. If it is positive, it returns true, else return false. Def matrix underscore multiply of a comma b. Def underscore multiply. Matrix multiply is used in the above. Matrix multiply a comma b. A is a one matrix, b is a one matrix. Used for the multiplication of two matrices. We can get. You must know the length of a matrix A matrices. Yes, n is equal to length of it returns the length of a result. We must almost we can initialize the zero. We must you should not be empty. The matrix we can get it should not be empty. We must fill it with a zero. Okay. For I range of for j n range of for matrix, you can use this logic. Range of n I range j n range of n. Result of ij is equal to sum of some zero already there. Sum of a of I comma k star into b of k comma j for k in range of n must be length of range of length of n. Return result after the matrix perspective. We must return the result of that. Def find underscore fixed underscore probably underscore vector. We find a fixed probability vector, so we can arguments p comma tolerance is equal to fraction of 1 comma 10 raised to 8 max iteration, maximum iteration up to the 1000 or less than 7 less than equal to 1000. Okay. N is equal to length of p, size of p must know the size of p. V is equal to one vector. V is equal to one vector of vector with equal probability, and for range of maximum iteration up to the 1000, we can create another vector v next, then compute the next vector by multiplying the current vector with the probability. Okay, multiply the current vector with the next vector, then take a sum of it. Sum of v of previous vector, previous vector v of j star ma- matrix of p j comma I for j in range of n, I in range of n. Okay, here we see check the if the difference between the current vector and next vector is within a tolerance, then return the converged, else return not converged. Raise value error if the fixed probability did not coverage within the maximum number of iterations. Okay, to get a matrix from input, get an entry. You must not fix it for the one matrix or any single matrix as a direct input. We must take from the console, so we can use the great get max matrix from input. So get matrix from the printf, enter the matrix size. N is equal to input matrix. P is equal to empty matrix. Or we can use a list operation, list for the matrix operation in Python. So we can use empty list or matrix printf row by row with space. Okay. Read the row from the user and convert the value into fraction. We can read first row and convert it into fraction, second row convert it into fraction. So this way, if length of row in not equal to length of a row, consider first row, if length of row not equal to n means number of size. Okay, so we can raise a error. Later p append row, append means it is adding row to the empty matrix p. Okay, return p. Okay, diff print smallest fraction or a vector means we can get a any largest denominator on the fraction form for the probability fixed vector. So we have to minimize the smallest factor among that. So we can use the smallest factor, smallest fraction underscore vector of vector differ. Simplify underscore fraction is a fraction is a function used. Fraction is equal to fraction dot limit of denominator. Reduce the fraction into simplest form. This line and return f fraction numerator underscore, it converts the converts the fraction into string. as a string. Printf unique property vector is in simplest form is we have for 3 cross 3 we have 3 unit vector in unique fixed property vector, so we can print all three, so we can use a loop for f in vector print simplify matrix, simplify fraction of f. Okay, okay, let's get the input from the user. P is equal to get matrix from input. Get matrix from input, so input is a is a function used in the above code used for the user in it. If is regular stochastic matrix is a function used for the p is a input from getting matrix input from the user or console. It is that printf matrix is a regular else is a stochastic matrix. Then we can use fixed vector any probability vector fixed for find the underscore fixed underscore probability underscore vector of p is equal to print. Okay, we already can compute the probability vector, so we must print in smallest fraction form. So print underscore smallest underscore fraction underscore vector fixed vector, it can print the simplest form of the fixed vector, else matrix is not a regular stochastic matrix. Okay, run. Let's 3 cos c. Okay, 0 1 0 0 0 1 1 by 2 space 1 by 2 space 0. It must be stochastic. Okay, it returns the matrix is a regular stochastic matrix. The unique pixel probability of vector in simplest form is 1 by 5 2 by 5 and 2 by 5. So you can return. Let's run one more time. Okay, run one more time. Enter the same 3 and enter the same, but we have to we have to look it for a not stochastic matrix. 0 1 1 and 0 1 0. It must not be stochastic because it is already error in row 1 plus 1 is equal to 2, so it must not be stochastic. So let's see. No, it print as the matrix is not a regular stochastic matrix. Okay, thank you all. Okay, we solved in programmatically in using program Python program. We can solve the given problem. Then theoretically we can see the result in this in that in it. So P is a matrix are given 0 1 0 0 0 1. Let's check the entries. I will give same is a regular stochastic matrix, and also find the associated unique forward vector. Okay, we have solved theoretical. We can get in a vector a b c, and we can have a plus b plus c, and sum of these first row, it is a row, is equal to 1. It must be 1, it should be 1. Okay, we have to prove that regular stochastic matrix means the given matrix must be stochastic only, so that bp is equal to v. We can solve the abc, and after using the a plus b plus is equal to 1, we can get in c by 2 is equal to a, c is equal to 2a. Call equation number 1. A plus c by 2 is equal to b, 2a plus c is equal to 2b, equation number 2. Then p is equal to c, b is equal to equation number 3. Okay, we know that a plus b plus c is equal to 1, a is equal to 1 minus b minus c. Put equation in 2, the O equation a is equal to b in equation number 2, 2a plus c is equal to 2. Then let's 2 in the place of a we can have 1 minus b minus c plus b is equal to b. 2 minus 2b minus 2c plus b is equal to b. 2 we have 2c 2c minus b is equal to b. We have okay 2 minus 2c is equal to 3b. 2 minus from the equation 3 in this step from equation 3 b is equal to c, so therefore can is equal to 2. Instead of c we can use b equal to 3b. We get an b value 2 is equal to 3 plus 2b 5b 2 b is equal to 2 by 5. Okay, c is equal to 2 by 5, a is equal to 1 by 5, a is equal to 1 by 5. No, we can get in same values as in programmatically we get solved. We get 2 by 5, c is equal to 2 5. This is a fixed probability vectors. Okay, thank you.